Okay, so today we're going to talk about some different concepts when it relates to forces. The first concept is something called inertia. Now, you probably heard this word, you probably heard it used in maybe like science movies. You may have even used it yourself, but maybe you weren't exactly aware of what it truly meant. So, the word inertia means the tendency of an object to resist a change in its motion. And as you're taking notes today, I've given you a new set of guided notes, and any words that you see in red, you need to write down. And they should be a blank for you to fill in those words. So the first one is resist a change in its motion. So all that means, and you don't have to write this down. If you want to, you can in the space provided, like somewhere on the side. But this simply just means, the likelihood of an object to not move. Okay. So what this means is that the velocity, or we know that that means also the speed and direction of an object, is going to remain constant unless a force changes it. So there's two ways you can think about this. So if something is still, like let's say a ball, okay, the speed of this ball, which right now if it's sitting still is 0, I'll say meters per second, and the speed of this ball, or the velocity of this ball, is going to remain constant, or it's going to remain at 0 unless a force changes it. So what this pretty much means is that unless somebody kicks it, unless a wind pushes it, unless some external force applies to this ball, it should never move. Okay, and that's a pretty easy concept to understand. We know things don't just move on their own. There's nothing's just magic. Things don't just walk around. Things have to have some kind of force in order to make it move. Also, another way you can think about this is that if a ball necessarily, okay, let's say the ball is actually rolling in some direction, okay, that ball will remain in that motion. It will remain moving unless a force changes it. Now, if the ball is rolling on the ground, for example, there has to be something that makes it stop. Okay, otherwise, according to the law of inertia, the ball will remain going at that speed constantly unless there's a force that changes it. So the force that would change it if the ball was rolling on the ground would be the friction, and we'll talk about friction more tomorrow, that is between the floor and the bottom of the ball. So the surface of the ball versus the surface of the floor, there's something called friction there, and it makes the ball come to a complete stop. Okay, so in other words, if an object is at rest, it should stay at rest unless a force causes it to move. And that right there is the big concept that you should be familiar with. Okay. After this, you're going to get a chance to mess with a cup, an index card, and some coins, and you can see, and you'll be able to see that if you move the index card fast enough, the only force that applies to the coins after the index card is removed is gravity pushing down. So if that's the only force and the index card is removed, the coins should fall in the cup. Now, if you do not move these fast enough, the force of the surface between the index card and the coin will interact with one another, causing the coins to move somewhere else. But if you can remove them fast enough, you can move that index card fast enough, the surfaces between each other will remain frictionless, and only the force that's moving down, gravity, will push the coins down in the cup. You guys have seen this. You've seen it probably on like a magic show or something like that. You may have done it yourself. Also, the same concept applies if you, for example, try to take off a tablecloth on a table. If you can remove it fast enough, all the things on the countertop should stay the same. So how does inertia relate to mass? So the greater an object's mass, the greater its inertia. So the more it resists moving. And this makes sense because it's going to take more force to stop a bowling ball, for example, by swatting it with a paddle than it does to stop a tennis ball. So if you had a paddle, okay, and you had a bowling ball and you had a tennis ball, if you're going to use this paddle, you would need a greater force here than here, which just means, and the reason is because of its mass is related to its inertia, or its resistance to movement. Okay, so here you're going to be more likely to not move than here. So this idea of inertia is also called the law of inertia, which we also can describe as Newton's first law of motion, which states an object moving at a constant velocity, which is also known as a constant speed and direction, keeps moving at that velocity unless an unbalanced net force acts on it. We've already talked about unbalanced net forces. We know that if an unbalanced net force has occurred, that must mean that some force made something move. A balanced force would make nothing move, so that must mean for this law of inertia to occur, unbalanced net forces must act on it. Now, we've talked about Newton's first law. The second law states that the acceleration of an object, which is just I'm going to put this, triangle means change, so the change in velocity. So the change of velocity of an object is in the same direction as the net force on the object and can be calculated from this equation. So this acceleration can be equal to the force, okay, on the object and the mass of it. Okay, so this tells us how forces, how mass, and acceleration are all related. So let's talk about the two different relationships here. The first one is between forces and acceleration. So the greater the force you apply to an object, the greater acceleration of the object. So if I barely push a ball, you won't see its speed change very much. If I push the ball a lot, if I push it very hard, you should see the acceleration increase dramatically. So the example here would be tapping on a soccer ball with your foot produces a small acceleration, but kicking the ball produces a large acceleration. And those are how the relationships between force and acceleration occur. The next relationship is between mass and acceleration. So the greater the mass of an object, the less acceleration the object with the same force applied. So the example here is using the same force, you can hit the ball further than a softball. Okay, so what that means is that using the same force, so if let's say 10 newtons, you can hit a baseball further than a softball because the baseball weighs less, so it has less mass than the softball. Okay, which means that if this is less, the acceleration is greater than this guy. Okay, so we can also use Newton's second law formula to calculate net force. Just reorder it. This is the main equation that you're going to see, and I want you to write this down. F equals ma. Now we're going to solve a simple equation. You push your friend on a sled. Your friend and the sled together have a mass of 70 kilograms. If the net force on the sled is 35 newtons, what is the sled acceleration? So what I do is I write down everything that the prop gives me, which is net force of 35 newtons. The friend and the sled's mass together is 70 kilograms, and we want to figure out the acceleration. Now I'm going to draw a small triangle here, and I'm going to put how it should be in that triangle. So F, M, and A. And if we cover the A up, you should see that there's F over M. So now I have that A equals F over M. So in order to do this, I can just plug in what I've got, which would be 35 newtons. This is my F. This is my mass. So F over M equals this number, 0.5 Newton kilograms. And what you can do is that you can see literally how we can get the units for acceleration, which are meters per second squared. Remember that, by using the actual newtons for, the units for newtons, which is kilograms meters over second squared, dividing that by 0.5, dividing that, yes, that's right, dividing it by the mass right here, and then those cancel out, and we're left with meters over second squared. So our units would be meters per second squared, and our answer would be this right here. It's 0.5 meters per second. I hope that using the guided notes and going through a simple equation has helped. If you have any questions, please ask me after the video. Thank you.